Alright, so my name is Matthew Gordon, and in this presentation I'll be talking about my seam carving project. I'm a third year student and I'm graduating early. So just to get started, what is seam carving? So seam carving is the process of reducing an image size, but unlike cropping, you're not deleting the background. But also, unlike traditional resizing, you're also maintaining all the important features without shrinking it down. Seam carving finds the low-cost paths across the image and removes one path at a time. So that's what I'll talk about. So the approach to do this is to first find a seam in an image, and you do this by basically taking the image, and what I did is I converted it to gray so that it was just a single 2D matrix, and I could easily convert that to a gradient magnitude or an energy magnitude so that I could find the energies at each pixel or the change. And so depending on the dimension, X or Y, for example Y, you would start at all the columns from the bottom, and you would start at each one and you would go up and check the energy of the left, middle, and right pixel. And also, of course, going along the x-axis, you would check top, middle, bottom. But you'd find the energy, and then you'd find the lowest energy, and then from there you do it again. Go up, 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 and you'd be calculating the total energy. And you do that along all the columns. And the one with the lowest energy, the seam with the lowest energy, is what gets returned back. And so I made these wrapper functions around find seam, and the find seam would return an array representing the seam, which is the length of the axis you chose, and each position, right, each index would represent the value at each index would represent the actual value along the other axis at which point the seam is at. So these wrapper functions, add rows and add columns, would basically find the seam, and then it would basically make a smaller image and take everything to the left of the seam and everything to the right of the seam and combine them. And also I made a convert image wrapper. I made two of these that actually convert the image to a desired size and also to a desired scale. So here are some results. You can see removing 50 rows from this image didn't do much to change the main features. Here, removing 60 columns, changed a little bit here, there's some warping, but otherwise pretty good. Here, the city, right, you barely see any change here, removing 20 rows and 50 columns. You can see the cars and the buildings over here get a little smaller, but otherwise, not much change here. This is my favorite one, it's the tree, because the tree itself barely changed at all, right, and you still see everything else around it, which I think is amazing, and we shrunk it down a lot. And the ocean is also a really good one. We scaled the height down by 0.85 and the width by 0.7, and it still looks like a perfectly normal picture. So the pros and cons of this: you get accurate resizing without making much sacrifice, and you can also optimize the algorithm in a little ways that I'll talk about in a second. But the cons are that it can be very computationally expensive and there could be unpredictable artifacts. So one improvement we can make is to make the find seam more flexible. By instead of doing 3 pixels, we can go 5 or 6 or more. That would make it more flexible going around, larger objects. And we can also change it from using MATLAB code to something like C++. That would make it go many orders of magnitude faster. And also the addition of rows and columns, I made that just duplicate the seam, which isn't working very well, so I think we can make that a little better. The biggest challenge was to organize the code, figuring out a good structure to use, and also making the find seam algorithm correct. And the potential applications of this are websites. Obviously you want to shrink the image to different devices. You can save storage by only using one image and applying this algorithm to use it for different devices. And you could also use it for video game texture rendering in different areas and different scenes. You can render the images differently. Alright, that's my presentation. Thank you very much.